Okay, welcome to Chemistry A, Lesson 1.02, Chemistry and Society. So these recordings are meant to be a quick overview of the lessons. I try to highlight the things that I know are going to show up on tests and quizzes, though I still highly recommend reading the lessons as well. So the objective for this lesson was to expose you to different kinds of chemistry so that you can know what sorts of things chemists study and be able to kind of, based on a description, match a type of chemistry to what that person's doing. So, chemistry at its basic, most simple definition is the study of matter. So, matter can be super, super tiny, as far as down to the atom level, or molecules, or you can deal with larger matter, like compounds and mixtures. All right, so just pretty much anything that you can think of that exists and takes up space, that's matter. And chemists study it, what it's made out of, how it works, how it interacts with each other, things like that. So this is something that we'll focus on in more detail in class, but I want you to pause the video here, read through these, see if you know if either any of these statements are true or false. But then as you go through the lesson, keep these in mind, because this lesson should help you decide if all of these statements are either true or false and provide you with some evidence why. So there are 5 types of chemistry. I highly recommend taking some notes. The first, starting with the oldest, is inorganic chemistry. And that's the stuff that the original, hundreds of years ago chemists studied. A lot of the laws and things like periodic table and just basic ideas came from inorganic chemists. Current inorganic chemists are going to focus on non-carbon-based compounds. Oftentimes they'll discover new elements, that sort of thing. So some notable scientists are Joseph Priestley, who discovered oxygen, Antoine Lavoisier measured matter before and after reactions and found that everything that goes in comes out. John Dalton created a very, very simplistic old version of the periodic table. Another person that we'll talk about eventually is going to be Mendeleev, who made the first variation of our modern periodic table. Organic chemists study carbon-based compounds. That is the base definition of an organic chemist. So if you see that word organic, you should think carbon. Getting into some more specifics, organic chemists are going to focus on carbon compounds outside of living things. So most carbon compounds have something to do with life, but, for example, like the ways you can use oil for gasoline, fuels, making plastics, different just kind of chemical interactions outside the living body is really what an organic chemist studies. Whereas a biochemist also studies carbon compounds, but specifically how they interact in living things. All right, so an example of this would be Fritz Haber and Carl Bosch created the Haber process, which makes ammonia really quickly, which is needed for fertilizer to get plants to grow. You can also think of it as somebody who studies like photosynthesis, cellular respiration. Those would be biochemists. Things that are specifically related to how chemicals help living things do what they do. So, go ahead and try this practice one. So what kind of chemist would use chemicals related to plastics? All right, so far we've talked about these 3. Pause the video if you need some more time. But the best and correct answer here is going to be your organic chemist. All right, because plastics are things used outside the living body. They are a carbon compound that is derived from oil. Benzene is specifically a chemical involved in some plastics. All right, so best choice there would have been organic chemist. Physical chemistry studies the interaction of energy and matter. All right, so this could be, like measuring how much energy goes in or out of reactions. This could be electricity and matter. It could be, transfers of energy, melting processes, things like that. So a lot of it ties into physics concepts as well as chemistry concepts. It really merges the two. And then analytical chemistry, they have their own subset, but honestly, most chemists do a variation of analytical chemistry. All right, so analytical chemists are focusing in on questions, measuring, how much of something, what it looks like, how it forms. A big contribution of analytical chemists is a thing called the mass spectrometer. So the gentleman over here is the one who got the Nobel Prize for that. And a mass spectrometer is this machine, if you've ever watched TV shows like, say, Bones or like a CSI sort of thing, you put the chemical in and then it spits out like, oh, there's carbons and there's hydrogens and there's sulfurs, and hey, the smart person says, oh, this is blah, blah, blah. That was a mass spectrometer that they're using. So, and again, we'll talk about this in more detail in a live class, but just, now that you've gone through, you've been introduced to the different kinds. If anything still doesn't seem quite so sure, let's make sure we read the lesson as well.